Hello, this video will go through sequence and notation objects. Okay, so these are the contents that we're going through. Okay, this whole lecture is mostly on sequence record. Okay, how to create a sequence record, what is sequence feature, how to format, and how to modify a sequence record. Okay, sequence record object. Okay, so what is sequence record? Okay, other than the sequence class that we learned last lecture, okay, we have a sequence record class. Okay, defined in this module. Okay, bio.seq I refer as sequence. Okay, seq sequence record module. Okay, so what is this class for? Okay, this class allows higher level features such as identifiers and features that we're gonna learn more. Okay, to be associated with the sequence. Remember last week when we go through the sequence class, all we need to key in is the ID, number or the name, okay, the name itself, the sequence, and lastly the alphabet. That's all. Okay, but sequence record allow you to record even more higher level features that we'll go through later. Okay, and more what do you mean by feature is like more information about the sequence itself. Okay, more importantly, this is important. Sequence record is important. Okay, when you are dealing with richly annotated sequence data such as GenBank file. Okay, FASTA file, as you can see from last week, okay, FASTA and GenBank file, they are two different kind in terms of the format. Okay, FASTA file will contain less information as compared to GenBank file. Okay, so this richly annotated sequence data, okay, the GenBank file, okay, when you deal with it, of course you need a higher class way to record the sequence, which we use sequence record. Okay, sequence record class is the basic data type for the bio.sequence.io sequence input output interface. Okay, so whenever you use a sequence, you pass a file, okay, it will be a sequence record class. Okay, so sequence record class offers the following information as attribute. So later we're going to see example, but I will just describe to you first. Okay, tell you each one what is it about. So if you type if you have a sequence record, you type .seq. Okay, you will get the sequence itself. ID is the primary ID. Okay, which is the accession number. We call it accession name. Okay, which is common name. Okay, for that sequence itself. Okay, most of the time is also the accession number. And description, okay, human readable description of that sequence you have. Letter annotation, okay, means every letter, okay, it holds a per letter annotation using a dictionary style. Okay, this one we will not go much into detail. Okay, annotation, dictionary of additional information about sequence, and okay, this one also same annotation will not go very deep into detail, but features will go very deep into detail later on. Okay, a list of sequence feature objects with more restricted information about the features on the sequence. Okay, so like later we'll see okay, so like where is the CDS, okay, what gene and what's from which position to which position in the whole sequence itself is the CDS. Okay, which part is the translated protein and stuff. Okay, and lastly .dbxrefs is a list of database cross reference as strings. Okay, so the references of this sequence. Okay, so for example, we want to use this GenBank file. Okay, Drosophila. Okay, sons of cellulose. Okay, so if you go and click on this, okay, you go to hyperlink and you will see the sequence itself. Okay, or you can download from Olive. Okay, so what will the script do over here? So import from bio, you import the sequence.io. From here, what does it do? Okay, it will create a list, okay, such that, okay, by the way, this one only contain one record. So actually here you can just use sequence.io.read. Okay, but if you're not sure, it's okay, never mind. Okay, so sequence.io.pass. Okay, so remember, pass through the file means you load through the file, then you load through all the records. Okay, so you will look through for all the iterate all the record inside this pass file, inside this file. Okay, then after they want, so you create a list from here, then they get the 0. Okay, means the first element in the list itself. Okay, So after I ask you to print the name, the description, the length of the sequence. Okay, so you see this. Okay, so GBREC. Okay, GB record. Okay, GB record. Okay, save it under this. So my first record in this GenBank file. Okay, I ask them to print, because how do I know first? Because here there's a square bracket 0. Okay, print the name. Okay, then after that name, after that plus. Okay, which means you print out the name of this GenBank record, the first one, the GBREC. Then after that, print the description also by using this dot description. Okay, remember just now the attribute. Okay, the description. So you print out this and this. Okay, then string. Okay, change it to string. Okay, length. Okay, length of this sequence. Okay, then after that, what else? Okay, this one is to print out the first 40 of the sequence. Okay, you see, so dot SCQ. Okay, so from the start all the way to 40, then plus dot dot dot. Okay, so we trying to print out the sequence the first 40 of them. Then after that, print out the annotation keys, and lastly, what the number of features inside this GenBank file. Okay, so output will be like this. So this is the name, this is the description. Okay, this is the length of the sequence, this is the first 40, dot dot dot. Okay, means there's 5,635 of them. Okay, but only print out first 40. So these are the annotation, comment, accession, on this. So these are all the additional info about this file, GenBank file. Okay, how many number of features? There's 3. Okay, later we will go more in depth on these features. Okay, so now we learn how to create so just now we have learned what is the basic attribute, what will it give us. So now how do we create a sequence record objects? Okay, we can do it from scratch, from GenBank file or from FASTA file. Okay, so let us start off with from scratch itself. From nothing, let us create a sequence record. Okay, so for the most basic, you just need a sequence object. Okay, so this is your sequence ATGC. Okay, so you import from bio.sequence record, import sequence record. Okay, change this sequence because I named this as the sequence of this. Okay, remember you need to, whenever you need to use certain function, you need to import them. Okay, then I change this to this file simple underscore SEQR. Okay, so equals to sequence record of this sequence. Okay, after that you print out. Okay, then this is output of sequence record, this sequence. ID I never put. Okay, the name never put, description I also never put. Okay, and stuff. Okay, so if you want to add ID, name, and description, you can. Okay, just simply dot ID or dot the attribute itself, then you key in whatever you want. Okay, so this one I made up. Okay, so description I made up the sequence to show as an example in this lecture 7. Okay, so the name is this, the ID is this. Okay, so I print out. Okay, so this is the outcome. Okay, annotation, same thing. Annotation is used for miscellaneous annotation that do not fit to any of the more specific attribute, like not inside the description. You don't want to put inside the description of the name or whatever. Okay, you can put under annotation, but in a dictionary way. Okay, so dictionary, remember, they will have the key, then the value. So for example, you want to put the evidence. Where do you find that sequence from? Okay, so evidence. Okay, I just made it up in my brain. Okay, for example, this is my evidence. So if you print this, will be the annotation part. Okay, so this one we'll touch a bit on it. If you want to learn more about it, you can Google. Okay. Okay, letter annotation, same. Okay, assign is a dictionary-like attribute which let you assign any Python sequence, strings, list or tuple which has the same length as the sequence itself. Okay, so for example, just now my one, okay, ATGC, okay, 4 letter, right? Okay, so over here my letter annotation will be 4 as well. Okay, then this maybe each of the number will be represent something with the letter itself. Okay, the quality of it or whatever. But here same, I will not touch into much into details. Okay, just showing you what it can do. Okay, so another, you can create a sequence record object from FASTA file. Okay, so we'll be using this file itself to show how to create a sequence record file from here, FASTA file. Okay, only contain just one record. Okay, so over here, right, when we run through when we try to pass a file okay, FASTA file or GenBank file with just one record, we can use, okay, we don't need to use the pass file, okay, because whenever you use pass file, you need to use the loop to help you run through all the record. Okay, what you can do is use this, the sister function of .read, okay, which only used to contain one record, okay, run through one record. Okay, so let's look through this, okay, from while import this, then after read, okay, remember to key in your file location, then this is your file. Download this from Olive, okay, and if you print a record, okay, this one is straight away. Okay, remember the sequence IO, the default way they save the record is sequence record. So over here straight away is a sequence record file. Okay, so this sequence record, okay, alphabet is the single letter alphabet, the ID is this, okay, name is this, stuff. Okay, blah blah blah. Okay, so this is a description and stuff. Okay, so you can key in and find out. Okay, note that when reading FASTA file, okay, now the attribute will be populated. Okay, so over here the reference won't have, okay, annotation won't have, letter annotation won't have, and the features also don't have. Okay, why? Because as I said last lecture, the FASTA file will not contain as much information as GenBank file. Okay, so usually we try to work with GenBank file. Okay, so we come over here. Okay, same, you can download this from Olive. Okay, you can click on this and go to the website and see for sequence yourself. Okay, so same thing, the function is run, everything, the code is around the same. Okay, just that you change the FASTA to GenBank, that's all. Okay, then what's the difference? Okay, as you can see from here, right, if you notice straight away, okay, look at this. Okay, alphabet was straight assigned for you. So this is the DNA, you will assign a DNA for yourself. Whereas for the FASTA file, right, if you see, okay, you give a generic alphabet, okay, single letter alphabet for the alphabet. But for here, they give you straight the DNA. So GenBank usually they provide more information and help you sort out easier. Okay, so yeah. Okay, sequence record, if you look through all the attributes, you can look through all this. Note that the ID and the name, there's some difference. The ID, this 0.1 is the version that you're looking at. Okay, so this is the real name itself. Again, note that this one, as I said, more specific alphabet as compared to the FASTA file for GenBank file. Okay, the name, okay, will come from the locus line, while the ID include the version suffix. Okay, means behind that the 0.1 is the version. The description comes from the definition line. Okay, so you must look through your GenBank, recall back your GenBank and FASTA file, how does it look like. Okay, you can use your WordPad and look through it. Okay, so over here, right, just now we know that the FASTA file for the annotation and features and the references, all this will not have anything. But over here, because GenBank file has more information, okay, if you go and find out, okay, there's a lot more. Okay, for example, here still don't have, okay, the letter attribute, but the letter annotation, but the annotation will have 13 of them. There will be 13 additional info about the sequence. Okay, okay, so for example, you want to see the source, then here everything will come up. Okay, then you can have the features as well. Okay, later we'll go more in depth into the features. Okay, so there's 27 features in this GenBank file. So we look through, right, from just now, it's the same file. Okay, this file, NC underscore 005816. This one GenBank file versus FASTA file. What can you see the difference? Okay, the difference is over here. Okay, most importantly, the difference comes over here. This one GenBank file can record more information. That's why you have the features and annotation all filled up. But FASTA file is just a simple way to record the data, the sequences and the ID, and lastly the alphabet. That's all. Okay. Okay. GenBank file do not have any per letter annotation. Okay. Most of the annotation information is recorded in the annotation dictionary. So same thing, this is a reference, okay, and stuff. All entry in the feature table, okay, is recorded in the sequence feature object in the feature list. Okay, if you look through your FASTA, the GenBank file, you will see this feature header. Then from there you can read through that. Okay, we'll go more into detail in the next slide. Okay, so what does sequence feature or inside the feature, what is the feature in this GenBank file look like? Okay, what is it about? Okay, it's to describe a region on the parent sequence, typically a sequence record object. Okay, describe a location of the object. Okay, typically in a range, and this feature class has a few other attributes, so it's another class already. Okay, so you know that sequence record will have attribute of feature, and this feature get another subclass, sub attribute, which contain all these. Okay. Okay, so to summarize, it's just like the feature will tell you what are the important area that you need to look out for inside the sequence, and which part is where the coding sequence part, region, okay, and stuff. Okay, later we'll look at example. Okay, so the sub attribute over here for the feature one, okay, feature class will have dot type. So what type of feature are you looking at? Is it CDS? Is it gene and stuff? Location. What is this location? It's just to tell you where is the sequence, because what you have is, for example, you get a 6,000 string, 6,000 length of 6,000 sequence as your GenBank in your GenBank file. Okay, however, the coding sequence, the CDS, okay, coding sequence only start from 2,000 to 4,000. Okay, then they will point out, okay, this part is the coding sequence. Okay, later we'll see example. Okay, so this usually, okay, sequence location dot ref, then dot ref underscore df. This one usually is none. So if you want more information, you can look over here. Okay, this one is the location typo. Okay, then strand. This one maybe is important. They will tell you, okay, because you know that DNA sequence come in base pair. Okay, so double stranded. For double stranded nucleotide, what it will tell you is, if you find out, okay, the strand, if it's 1, it means referring to the top strand. Okay, -1 is referring to the bottom strand. 0 means that the strand is important but it's unknown. None means it doesn't matter. For protein and single stranded sequence, there will be none if you find out this attribute. Okay, qualifiers is a Python dictionary, okay, of additional information about the feature itself. So usually the key is just a one-way description. Okay, then the value is what the actual information will be. Okay, so for example here, qualifiers. Okay, so it's just like so-called the sub-feature of this feature. Okay, so you need to know more information, like all the information about this feature. Okay, so evidence. Okay, for example, the key is evidence. So what kind of evidence? So this feature, how do you get this feature? For example, for this one, okay, the evidence is not experimental. It's not from web lab. Okay, it's through calculation, computation. Okay, so if you look through this file, okay, and you look through the GenBank file and look through at the middle part, okay, where the features, where you see the header features. So this is how it look like. Okay, so you have different features. So each of these like that is considered a single feature. You see this one is start of the second feature, but I cut away already. Okay, I cut halfway. Okay, below there's small stuff. Okay, so each one is just, this one is one single feature, this is another one, then below maybe have more. Location where 1 to 5, 6, 3, 5. Okay, the first index to the last one. Okay, these are the qualifiers. Okay, this is the key, this is the value. Okay, so these are the more so-called the description or the more information about this source. Okay, where is this source? Okay, so organism is this, mode type is mRNA, and this reference chromosome and all this. Okay. Okay, you may take some time to understand this, but through a tutorial you will get to understand more and more. Okay, you really need to key in yourself and go and find out. Okay, so let's continue with this. Okay, for example, how do we make use of, in order for us to understand all this, okay, let us go through one example. Okay, so for I in the range of features, for this, I save this under, remember just GBREC. Okay, we save the just now that file lah. Okay, this file. Okay, this file under GBREC. Okay, this file under GBREC. So you run through all the features for I in range of length or the features. So total, how many features are there? Remember just now we got 3. Okay, we got 3 of them. Okay, so you run through one by one. Okay, feature will be equals to, for example, the first one 0 lah. Okay, so at the first, okay, the feature number. Okay, then I will put which feature is it. Okay, then after that the type, what is it? So a dot type. Okay, the strand. Okay, which strand is it looking for? Okay, location. Okay, start location. Okay, the method they use. Okay, the attribute they use is dot start dot position. This is how you plug out the start location, and this is how you plug out the end position. Okay, then after that, for the qualifier, then you key in all the qualifier keys. Okay, so let us look through what is all. This is just the script of it. Okay, let's see the outcome, then see whether you can understand more. So for what you print out, okay, so the first one you give feature 1. The first feature 1 is feature type is source, and it's at the top strand. Okay, the starting location is 0, ending location 5635. Okay, then these are the qualifiers, all the key features, all the keys. Okay, so this feature number 2, gene. Okay, we are looking at gene. Okay, so starting is 0, so the whole string itself is a gene. Okay, so these are the keys. Okay, more importantly is number 3. Let's look at number 3. Feature number 3. Okay, the feature type. Okay, means remember the feature is more information. Okay, or the important information about this sequence record. Inside this, from 0 to 5635. Actually, the coding sequence where you start doing all the coding is at from 398 to 5189. Okay, so this is the coding sequence that they start and end. Okay, and at the top strand, and all these are the key. Okay, so this one, so feature is very good. They will tell you all the important features, okay, all the important information about this sequence that you are looking at. Okay. Okay, so next, okay, so we go through about sequence feature already. So you may not fully understand, so try to repeat the whole video, repeat the sequence feature part, okay, or you can try the tutorial question itself, okay, then from there you can learn it for yourself. Okay, it's not that easy, I can understand, okay, but you need to try it on your own, okay. So we can use the format method that the sequence record class offer to format a sequence record to output file format that supported by this sequence IO. Means that it's FASTA. You want to change it to FASTA file or whatever. Okay, for look at this example. Okay, import sequence record, import this file alphabet, import this generic protein. So this is my record, sequence record. This one create myself, I type myself. This is the ID. Okay, and this is the description. Okay, so I can change this sequence record into a FASTA format by using dot format. Okay, FASTA. So this record will format it into FASTA, and if you print out, is this what happened. Okay. Okay, note that the FASTA, the format method only take in one single argument. Okay, so if you got more, then you cannot use this. Okay. So if you want to modify sequence record, you can do that as well. So let's look at a few way of modifying the sequence record and what are the stuff that they keep and take away. Okay, when you slice an object, right, it will give you a new sequence sequence record object. It will give you a new sequence record covering just the part of sequence that you just slice out. Okay, so note that the per letter annotation, if there's any, they will slice out as well. Any features fall under within this new sequence will be preserved. So that's why it's good. Okay. Okay. Let us use this GenBank file again to use as an example. Okay. So remember just now we run through. So the record is this one. The length is 5,000 plus. 9,000 plus. I mean. Okay, 9,000 plus. Okay, 9,609. Okay, total feature is now 27. Okay, for example, okay, out of this whole genome, right? Okay, all I need to see is just the YP_R22245 gene. Okay, this is just the code, the ID code. You just want to see the gene. Okay, if you go and find is the number 19 feature and number 20. Okay, so this one describe. Okay, from 7,788 to 8,088. Okay, within this location, okay, you will find a gene. Okay, which is the coding sequence. Okay, where these are all the qualifiers and stuff. Okay, all the information. Okay. Okay, so what I suggest is let us slice the parent sequence, which is the 0 to 9609. Okay, we just want the 770 to 8100. Okay, this is enough to include this whole gene itself. Okay, and we see how many features we can get. Okay, so if you slice through this, remember this one, right? Start from 7788 to 8088. So I slice 7700 to 8100. So confirm or contain these two features. Okay, so let's see. Okay, if you cut through this, so these are sequence. So you print number record, total 400, and you see, okay, the sub record that you have just sliced through, the features will still be preserved. Okay. Okay. Note that, as I said before, okay, after they slice already, the features will still be preserved. However, the location, the index will change. Okay, because now you don't have from the 27 of them you start, because previously it's 19 and 20. However, after you slice, it will become the first feature in this new parent sequence. So when your sub record, okay. So at the 0, this is, so the location will change as well. It will not be 7788. So I start from 88. Okay, because we start from 7700. Okay, until 388. Okay, so these are the information that you can count. Okay, so most importantly is outcome I'm trying to say is that you will preserve the features if you slice a sequence record. Okay, note that these two annotation and the references will be omitted. Okay, it's impossible to know if these features still apply for subsequent. Okay, however, the name, ID, and description will be preserved from sub-record. Okay, you know that this sub-record, right, is not the whole complete sequence, correct? So if I want to change, I can change also. Okay, so just rewrite name. Okay, so as follows. So description I change to partial, don't change to complete sequence. Okay, so you can format it into GenBank file. Okay, so if you want to add sequence record, you can do that too. You return a new sequence record, any common per letter annotation will add as well. All features, okay, with their location adjusted. Okay, so all features will be preserved as well. Any other common notation will also be kept. So usually they will add preserve a lot of stuff. Okay, so let's look at this. Okay, suppose that you have this file, okay, same file, same GenBank file. Now suppose it's circular genome. Okay, circular genome means like for example 0 to 9609. So for example, start from here. Doesn't mean you must always start from here. You can, because it's circular, you can start from here, then count the 9000 plus. Okay, so now what we're going to do is try to slice it and add it them together. Okay, so this is a record. Okay, these are all the references and stuff. Okay, since it's a circular genome, okay, I can shift the origin. So I start from 2000 onwards. Okay, 2000 onward. Okay, then after that, I add it from the end, then add to the start, then all the way to 2000. So this one, as a circular, I just change the starting origin. Okay, instead of starting from TGTAA, I start from the 2000, which is GATA. Okay, so we change. Okay, notice that the features will still be the same. It will be shifted, will -1, but around the same. Okay, one of the feature with the source feature will be lost. Okay, but most of it will be preserved. Okay, references will not be carried forward. Remember, annotation will also not be preserved as well. Okay, but if you want to add, you can go and add it yourself. Okay, so via this code, so you can look through this and try to run this. Okay, reverse complement, you can do that as well. Okay, reverse complement is just to find the reverse complement of the sequence. It's the same as the sequence object that we learned last week. Okay, any features are transferred with location and strand is recalculated. Per letter annotation will be copied and reversed. Okay, ID and stuff will not be transferred by default. Okay, because you reverse complement it. So the ID, the name, the dictionary annotation, and the references will not be transferred by default. Okay, however, they take in certain arguments. So if you set the argument to true, you copy the old record. If set to false, it will not. You will use the default. Okay, default, which is they will lose it. Okay, so for example, okay, this is you put your file location. Don't use mine. Okay, so GenBank file. Okay, so if I print, okay, look through the result. Okay, the ID and stuff. Okay, after that you try to find the reverse complement and you see the result. Okay, you realize that okay these two, the references and the annotation will be all gone. Okay, but however this one if you print out, right, okay, all these will be preserved. Okay, this one I changed the name, okay, by putting this ID equals to the ID number underscore RC. Then this one length will still preserve. Okay, the features will still be preserved, but this one reference, cross-referencing and the references and the annotation will be gone. It will not be preserved. Okay, so yeah, so this comes to the end of this lecture. Okay, I understand that this lecture will not be that simple as compared to the rest. You need some time to read through and understand. Okay, remember you always can go to our reference text and read through. There is more detail, or if not, you can post question in the forum and stuff. Okay, so yeah, that's it for this lecture. Thank you.